So let's discuss Diffie Hellman key exchange. What exactly it is. So here is the thing. So if you want to exchange some message encrypted with someone, you need to have some sort of key, yeah? So thing is either you meet the person whom you are going to exchange a message with beforehand and exchange the key and carry out the transmission of your message. But the thing is, it might be the case that the person you are sending message to, you might not have met, or it might not have been possible to meet him or her, and hence is there a way to exchange a key without ever knowing the person and without a risk of leaking the key, so that the message we are communicating is not secure anymore, yeah, if we end up leaking the key, yeah. So whole objective is to keep the key secret from any other party. It is just the two party who are communicating have the key, yeah. So let's try to see this thing. So say we have two party, Alice and Bob, yeah? There's a fantastic video from computer file which gives an example of mixing two colors, and it says once you mix the color it's difficult to unmix, yeah. So that's the philosophy. So let us say we have a number n, yeah, which is public. Anything here is public. Anything here belongs to Alice. Anything here belongs to Bob. That's all. Yeah. So yeah, let's begin. So Alice is going to decide one number A, and Bob is going to decide the number B. Now G is also public. Okay. Yeah. G is a member of 1, 2, 3 up to n. Yeah. Now what we are going to do is the following. Yeah. So G is public, so one can consider A times G, yeah, which will be further transmitted. So this is public channel, yeah. So Bob receives AG. Now Bob knows B, so he can do this thing, yeah. So good. Let's denote this thing by, let's say, K. And now what Bob does the following. He has the B, so he computes BG. G is public, and he sends BG to Alice. Note that it's difficult to figure out B because we do not know, because discrete log problem is difficult to solve. Yeah. So he sends out BG to Alice, and now what Alice does, she has A, so she computes this thing. Now note that BAG is same as ABG. You can imagine this thing as G equal to, let's say, 5, 3, let's say 4. So 4 times 5 times 3 is same as 3 times 5 times 4. Yeah, that's the idea. So you can notice over here, you can observe over here that K never went through this public channel. Never. Okay. But even though that never happened, Bob and Alice has the same number, you see. So this is the key that we are going to use in order to encrypt the message, decrypt the message. That's the whole idea of Diffie Hellman key exchange. And here we stop. Thank you very much for listening. In case there are any questions or suggestions, please feel free to do some suggestion or ask questions. Yeah. Thank you so much.